Hey everyone. So, have you noticed just how wildly fast artificial intelligence is changing lately? I mean, we are officially stepping out of that era where AI just sits there waiting for you to poke it with a prompt to generate a paragraph or an image. We are crossing into a totally new frontier. We're talking about transitioning from basic, passive chatbots into fully autonomous AI ecosystems that actually get real work done on your behalf. So today, we're jumping right into an explainer of a comprehensive guide all about understanding, building, and scaling these really incredible AI agents. Let's get into it. Okay, to break this massive topic down into logical, applicable chunks, we're going to look at the shift from chatbots to agents, explore their anatomy, check out the 5 levels of capability, and then finish up with how we actually manage, secure, and evolve them in the real world. All right, Section 1, From Chatbots to AI Agents. We're looking at a massive paradigm shift in software right now. To really understand agents, we kind of have to contrast them with what came before, right? For years, we've leaned heavily on predictive AI. And look, predictive AI is great, but it's passive. It excels at discrete, one-off tasks like translating a block of text, but it completely relies on constant human direction for every single step. Autonomous agents, on the other hand, are active. An agent actually makes its own plans. It figures out the next steps required to reach a complex goal, and it executes multi-step task loops completely on its own. So instead of just asking an AI to draft a quick email, an agent could research a target client, write a tailored pitch, send it, and schedule the follow-up on your calendar, all without you holding its hand. There's a quote from the guide that I absolutely love. It says, "Agents are the natural evolution of language models, made useful in software." And that just hits the nail on the head. It hammers home a really vital reality. LLMs, by themselves, they're basically just brains in a jar. The agent is the body that actually goes to work. It takes that raw reasoning power and wraps an entire application around the model so it can execute real tasks out in the real world. Moving on to Section 2, Anatomy and the 5-step loop. Let's look at how they actually solve problems. What's really fascinating here is how closely an agent's architecture mirrors our own biology. Think of the language model itself as the brain. That's your central reasoning engine. But like we said, a brain in a jar can't do much, so we give it hands. These are the tools, things like APIs, code functions, and databases that let the agent execute actions and manipulate the world around it. Then, to connect the brain and the hands, we need a nervous system. This is the orchestration layer. It handles memory, it handles planning, and it dynamically decides when the agent needs to think versus when it needs to use a tool. And finally, you have the body and legs, which are just the deployment services that let this whole thing run reliably on a server so users can actually reach it. So how does this anatomy function in practice? Well, it runs on this relentless 5-step problem-solving loop. First, it gets a mission, like a big overarching goal from the user. Second, it scans the scene, gathering context from its memory and its current environment. Third, it thinks it through and creates a strategic plan. Fourth, it takes action using its tools. And fifth, it observes the outcome of that action. Then, and this is the magic part, it loops right back around, synthesizing that new observation to figure out its very next move. Let's put this into a real-world customer support scenario. Say a user asks, "Hey, where is order 12345?" The agent doesn't just hallucinate a guess. It starts thinking, "Okay, I need to look this up, find the tracking number, and check the carrier." Then it acts by pinging the database tool. It observes the result, which is the tracking number. It acts again by hitting the shipping API with that number. It observes the shipping status. And finally, it synthesizes all of this and reports back to the user, "Your order is out for delivery." That is autonomous problem solving in a nutshell, and it's literally how companies are automating thousands of support tickets every single day. All right, Section 3, the 5 levels of agents. Let's see how these capabilities actually build up. Now, not all agents are created equal. In fact, agentic systems scale along a taxonomy from level 0 all the way up to level 4. Level 0 is basically just your core reasoning system, an AI with 0 tools. Level 1 connects to basic tools for simple, single tasks, like looking up the weather. But things get genuinely fascinating as we climb higher up this pyramid. At level 2, we hit the strategic problem solver. The superpower here is something called context engineering. This is the ability to actively select and package the exact context it needs to solve complex multi-part goals. For instance, if you ask a level 2 agent to find a highly rated coffee shop exactly halfway between an office in Mountain View and an office in San Francisco, it doesn't just freeze. It actually calculates the geographic halfway point first, and then it dynamically formulates a brand new search query for 4-star coffee shops in that specific midpoint city. It strategizes. But the real game changer happens at level 3. The entire paradigm shifts here. We stop trying to build one massive do-it-all super agent, and instead, we build a collaborative multi-agent system. Imagine you're launching a new pair of Solaris headphones. A project manager agent takes that mission and actually delegates it. It treats other specialized sub-agents as its tools. So it tells the market research agent to go analyze pricing, tells the marketing agent to draft the press releases, and tells the web dev agent to code up the product landing page. It's essentially mimicking a human corporate organization, just, without all the endless Zoom meetings. Section 4, Managing Agents in Production. Building one on a laptop is one thing, but enterprise production means entering the world of agent ops. So we have to completely rethink how we test software. Traditional DevOps is deterministic, right? If I put in X, I expect to get exactly Y every single time. But agents are stochastic. They are creative and probabilistic by design. So you can't rely on simple pass-fail unit tests anymore. Instead, Agent Ops evaluates quality using an LM judge. This means using another powerful language model to grade the agent's output against a really complex rubric, making sure it's accurate, helpful, and above all, safe. Because of this, Agent Ops requires some very specific practices. You have to measure actual business KPIs, run metrics-driven development against golden data sets of test prompts, and crucially, you really have to cherish human feedback to catch edge cases. But for sure, the most important tool in your entire arsenal is the Open Telemetry Trace. Think of an Open Telemetry Trace as a flight data recorder for your AI. It lets you peek under the hood directly into the agent's internal monologue. You can see exactly what prompt went in, what tool it decided to use, and what data came back. It is absolutely crucial because it's how you answer the why when something eventually fails. Section 5, Security and Interoperability, because we absolutely have to talk about trust in this new ecosystem. I want you to seriously think about this for a second. If an autonomous agent clicks buy, who is legally responsible? It's a huge question, right? This highlights a massive crisis of trust and accountability in the emerging agentic economy. When we have agents taking action on our behalf, especially irreversible actions, we need ironclad security frameworks. The bedrock of that security is a concept called agent identity. In enterprise systems right now, you have human users and you have deterministic service accounts. Well, agents are a brand new third class of verifiable principal. They need a secure digital passport using standards like SPEFI that grants them delegated authority. Because without this digital passport, a super helpful agent might accidentally email your entire company's private HR payroll data to an external client. By giving an agent a unique verifiable identity, we can implement strict, least privilege security policies. Once they are secure, these agents actually need to talk to each other. That's where open protocols come in. The A2A, or agent-to-agent protocol, functions as a universal handshake. It allows agents to instantly discover each other's capabilities and collaborate asynchronously. And what about that buy button we mentioned? Protocols like AP2 and X402 are being built to enable secure, machine-to-machine micropayments. This gives verifiable proof of user intent. So in the near future, your personal AI could negotiate and directly pay a server's AI for extra cloud storage, entirely in the background. Finally, Section 6, How Agents Learn and Evolve. Let's look at autonomous adaptation. Here's the thing. If an agent doesn't adapt to changing data and policies, it suffers from what we call aging. It just gets outdated. Level 4 agents avoid this by continuously learning on the job. They absorb runtime experience from their traces and human feedback, and they adapt to external signals, like brand new compliance policies. They actively refine their own prompts, which is that enhanced context engineering we talked about. And incredibly, they can autonomously create new tools. Imagine an agent writing a custom Python script on the fly to solve a problem it has literally never seen before. To see this actually happening today, look at the Google co-scientist. This is the ultimate example of a level 4 system in action. It acts as a virtual research collaborator that literally spawns an entire ecosystem of sub-agents. These agents then work together for hours or even days to systematically generate, critique, and evolve completely novel scientific hypotheses. They are driving real-world breakthroughs by continuously improving not just their answers, but how they actually evaluate ideas. Guys, this isn't science fiction anymore. This is exactly how we are going to discover new life-saving drugs and next-generation battery materials in a fraction of the time. But you might be wondering, how do we train them to do all of this safely? Enter the Agent Gym. This is a dedicated off-production simulation environment. Think of it as a safe sandbox where agents can run massive trial and error loops using synthetic data. It's basically a gym where an agent exercises, adapts to new rules, and masters new optimization pathways safely, long before it ever touches live, real world data. I want to leave you with this final provocative thought. If our agents are continuously learning, if they are collaborating in multi agent organizations and autonomously spawning brand new tools to solve complex problems, what will your team look like when the software itself becomes a self evolving colleague? The potential of these agentic ecosystems is absolutely boundless. And honestly, the journey is just beginning. Thanks so much for joining me on this explainer. See you next time.